Morning everyone, I'm just going to go through quickly the calculus for us, which is differentiation, or for a lot of you, you're thinking dy over dx, okay? So really looking at the equation, it will differentiate for it. You will actually, I will send you also an email with everything really we've actually have done on differentiation for us too. But looking at some questions, say for example, if I wanted to differentiate x in the power of 9, that would actually become 9x in the power of 8. So what you do is you bring the number down and then you actually take away 1 from the top. If you remember, one of the difficult equations was what if you just had x? Well, that just simply factorizes to 1, okay? Not factorizes, sorry, differentiates to 1. Same again, if I had, let's say, I've got 11x in the power of minus 4, well, that becomes minus 44x, and then that becomes minus 5 for us, because I bring it down and then I take away 1 from the top. Continuing on, let's have a look. So I've got g here, I've got 2t in the power of 7 over 2, so that's going to become 2 times 7 over 2, because I'm going to bring it down, t, 7 over 2, take away 1. So that becomes 7t, and then 5 over 2 as the power for us. Special cases that we need to actually remember: if you got a big equation like this, the first thing you'd have to do is actually expand brackets before you can actually differentiate. If you've got a square root, your square root, remember, square root of x is like having x in the power of a half, so that's a special case really got to think of. And also you've got a special case when you've actually got your number as a denominator. So say for example, I've got y equals to 1 over x squared. How would I actually differentiate that? Well, first of all, that is equal to x in the power of minus 2. So therefore I can differentiate this by dy over dx would be equal to minus 2x minus 3. Exactly the same if it was a larger question. So if you had, say for example this, or let's make it a bit harder, let's have 2x minus 5. So first of all, this becomes x in the power of minus 4 plus 1/2 x in the power of 5, and I've got to differentiate this, so dy over dx would be equal to minus 4x minus 5 plus 1/2 times 5x in the power of 4, so therefore minus 4x minus 5 plus 5 over 2x 4. So that'll be the plain simple differentiation. And that was actually the majority of the stuff we actually did on chapter 1. Why do you actually differentiate? Okay, the reason as to why you differentiate is to work out the gradient function for us. And so if you've got the equation of a curve, so I've got y, let's have a look. So the equation of the curve is y equals x squared plus 5x take 4. Why do we differentiate? Well, we differentiate to work out the gradient function. So this dy over dx, which is equal to, give me 1 minute. I mean, maybe I should have actually started charging my pen before I actually doing this session with you guys. But what you're actually doing is you've got the equation of the curve, which is y equals x squared plus 5x take 4. You differentiate first to work out the gradient function, and then they'll ask you to work out the gradient at a specific point. So the question will say, here's the curve, find the gradient at point 3, 4, let's say for example. So therefore you would have to differentiate first of all 2x plus 5. Remember, the way to differentiate a number, it becomes 0, so there's no point even writing that. And then we want to work out the gradient at point 3, 4. So the gradient at point 3, 4 is 2 lots of 3 plus 5. So therefore 6 plus 5. The gradient is 11. And a lot of these questions actually continue from using this gradient. Okay, so this is the gradient at that specific point. And basically, if you had a curve, your gradient at 3, 4 would be equal to 11. And what they actually do a lot of the time here, they'll ask you to continue this question with finding a perpendicular to that point. So obviously once you work out the gradient is 11, well, the perpendicular to that will have a negative reciprocal, so it'd be minus 1 over 11. Minus 1 over 11 even, guys, sorry. Minus 1 over 11. And then you've got y equals minus 1 over 11x plus c. Well, it goes also to the point 3, 4. So we can substitute 4 equals to minus 1 over 11 times 3 plus c, and so on, in order to actually work out what the value of c is. Blank empty space. So we've got the gradient function. Just kind of a quick look through everything here. No, that is exactly what we've just talked about. Again, obviously, I've got the answers too for yourselves. So the PDF that I've sent you, so have a look at what calculus actually is. It is exactly the same for more complex curves. Again, you can actually see here all the problem we've got is this is a cubic equation. Again, we'll have to differentiate it for us and then simply working out the gradient at a specific point. Same again for these questions. Now, why would you actually need the second derivative? Well, the second derivative, or the rate of change of the gradient, can actually tell you if you've got a maximum or if you've got a minimum. So it basically tells you the nature of the stationary point. That's why we actually use it for this. So you can actually see here we've got a maximum and here we've got a minimum for our curves. And if your second derivative is positive, you get a minimum. But if your second derivative is a negative, you actually get a maximum. So see if this question here, for example, number 5, say, it says, find a turning point for x cubed minus 12x plus 4. First of all, when you got a turning point, is when you're stationary, when your first derivative is equal to 0. So if the question asks you to work out a stationary point or find a turning point, well, you've got to actually put dy over dx equals to 0. So dy over dx is the first derivative. We worked it out when x is equal to plus or minus 2. So when x is equal to 2, we can actually work out what your y is, obviously. So you've got minus 2 and 20 into minus 12. And we need to actually work out the nature of that point. So what we do is we're working out the second derivative. So we can work out the second derivative, which is 6x. And again, obviously 6x because it's exactly the same thing. If we substitute x equals 2, at x equals 2, we're working out that this is bigger than 0, so therefore it's a minimum. If x is equal minus 2, we get minus 12, which is a maximum. And that's all you need for you to actually work it out. So remember, this is the nature of the stationary point. So the nature means if you've got a maximum or a minimum for us. But if you need to work out where the stationary point, and if you've got a stationary point, you put dy over dx equals to 0 to work it out. Again, you've got some example questions for us. Okay, these are some more problem solving questions really. Nothing crazy. Let's have a look. Again, you can see some examples where you need to prove that it's a decreasing function. But yeah, if you find that anything else that you actually need for us, please send a message. I can actually go through them with you. But that's pretty much the majority of the differentiation stuff.